We're looking at balancing equations, and so this is what I would consider to be a medium difficulty. There's an easy way and a hard way to do this. And I'm going to start writing, and I'm going to show you kind of the hard way, and then I'm going to back off and go back to the easy way. So this first stuff that I'm going to write down, I don't want you to write it down. So this is what we normally do, taking inventory of our different elements and then counting them up. So on each side, there's one iron. Nitrogens, there are 3 nitrogens here, and there's a 4th one. Over here, we've got 1, 2 hydrogens. Here's 4 and 5. And over here, we've got 3 hydrogens plus 4 more, there's 7. And then oxygens. 3 times 3 is 9. Here's a 10th one. Here's 3. Here's 3 more, there's 6. So just looking at this, the scoreboard here, this is going to be a wreck. And this is the way we normally do them. And if you do it like this, you could get it to balance. But like I said, this is the hard way. So I'm going to erase this and start over and show you what we're looking at. The first thing I notice is there's a lot of things that repeat here. For instance, NO3 shows up here and here. And the NH4 shows up here and here. And those 2 things have all of the nitrogens. There's no nitrogen anywhere else. And so we don't really want to change anywhere that's NH4 or the NH3. Or look at this, here's OHs. Outside of those 3 pieces, the only other thing we have is iron. So here's where you can actually start writing. So looking at what we have iron by itself on both sides. So I'll write it down. Then we have this NO3. It's a polyatomic ion, and it's actually NO3 with a -1 charge. The charge is not really important to the balancing. Just to refresh some memories, I'll put the charges here. Then we have the NH4, and we have the OH. That's plus, that's minus. And now I can take the inventory. So in the reactants, I have 1 iron, 3 of these nitrates. I have 1 NH4, and I have 1 OH. Then I look at the products. 1 iron, 1 nitrate, 1 of these NH4s, and 3 of these OHs. These are pretty simple numbers compared to that last one where we had 5s and 10s and 7s and 4s. This is going to be a lot easier. And now we can just balance it as if we were doing a regular equation. So my thought is maybe start with the the nitrate, and I want to make this 3. So I put my coefficient of 3 here. That makes 3 nitrates, but it also makes 3 of these ammoniums. So I have to update the scoreboard for everything. If you change one thing, there's a good chance you've changed something else. Now the only things that have different numbers are the NH4 and the OH. They're in the same compound over here, and there's 1 of each of them. And so putting a coefficient of 3 here changes both of these, and this looks like it's balanced. And a quick double check, and everything checks out. And so this is a lot easier. A couple other words on it. In my time as a tutor, some people really really despise the idea of not separating these elements. And so what I have those students do is maybe give it a letter. So like Fe, and my nitrate is going to be X, plus, let's make NH4Y and OHZ. And so it's just another way that you can do this. That's what it would look like. Or for even a few students, I've done something like this. The ammonium smells bad. Make a hydroxide frowny face. And these are all the same thing, whether you're using letters or the actual formulas or hieroglyphics, you're all going to get the same result. So the next one, if you want to copy down this equation and give it a try, then we'll see how it goes and we'll talk about it soon.